Hello everyone, I am going to explain some questions from miscellaneous exercise of chapter 7 from 12th class maths. So today we will start from question number 13 of miscellaneous of chapter 7. Question number 13 is, if y is equal to sin x minus cos y whole to the power sin x minus cos x, then find dy over dx. Since we have to find out dy over dx, means we have to differentiate the given equation with respect to x. So that's why first I wrote this given equation. Now when we observe it clearly, we'll find that these both the functions we cannot separate until we take the logarithm both the sides. That's why it is an implicit function, because we cannot separate them. So we are going to take log in both the sides. So after taking log both the sides, we will obtain the result like this. Now here we have to use the formula log m to the power n. And log m to the power n formula is n log m. That's why this power will come in front in the multiply as a coefficient. So there are two functions, sin minus cos x multiplied by log bracket sin minus cos x. Now we will differentiate it with respect to x. So when we differentiate, log y differentiation is 1 upon y. Then we have to apply the chain rule. That's why dy over dx. Now here these are the product of two functions. So when we obtain product of two functions for differentiating, first we have to keep any one function as it is and we have to differentiate the other function, and then in next step we have to differentiate the other function and first function we have to keep as it is. So students, here first I differentiated, in first term I differentiated log sin minus cos x, and then in second term I differentiated sin minus cos x. So here first, since I differentiated this, so I kept this bracket as it is, and log, since log x differentiation is 1 upon x, that's why when we differentiate log bracket sin minus cos x, 1 upon sin minus cos x will come. Now again we have to apply the chain rule in the bracket, so this brackets term we have to differentiate again. So when we differentiate sin minus cos x, sin differentiation is cos x and cos x differentiation is minus sin x, and minus minus plus, that's why plus sign came. Again I am explaining this first term. First I kept this bracket as it is and I differentiated log sin minus cos x. So when we differentiate log sin minus cos x, its differentiation is 1 upon sin minus cos x, and then we have to differentiate this sin minus cos x again by the chain rule. So sin x differentiation is cos x and cos x differentiation is minus sin x, and minus minus becomes plus. That's why we obtained here cos x plus sin x. Now since these both brackets are same, so they will cancel in next step. Now first we'll understand the second term of the differentiation. Now since here first I differentiated log sin minus cos x, so in second term we have to keep this log sin minus cos x as it is and we have to differentiate the first bracket. So when we differentiate this first bracket, sin x differentiation is cos x and cos x differentiation is minus sin x, and minus minus got plus here, and log sin minus cos x as it is. Means in these two terms, one by one both the functions are differentiated by keeping any one function as it is. Now here you can see these both brackets are same, so they will cancel, and then in both the terms this cos x plus sin x is same, so we will take it common, and when we take it common, here what will remain? 1, because they will get cancelled and it already came outside, so here what remain? 1, that is this 1. Now from here I took this bracket common, so what is remain here? Log sin x minus cos x. Now here in this side this y is in divide, so when we shift this y here, it will come in multiply. Now we will replace the value of y from the given question, that is the value of y is this. That's our required answer, that's it. So this question is not so tough, only we have to take care that since it's an implicit function, so we have to take the help of logarithm and then differentiate by using the formula product of two functions. Now we'll move to the next question of the same exercise, that is miscellaneous of chapter 7. Now here y is equal to sin bracket sin x is available to us, and with the help of this y we have to bring this result. So there are three terms in the result. The first term is d square y over dx square, means it's the double derivative of y, and then tan x multiplied by dy over dx plus y multiplied by cos square x equal to 0. So to bring this result, first we want the first derivative, that is dy over dx. Then whatever answer will come, we will differentiate again to obtain the second order derivative, and then after obtaining first order derivative and second order derivative, we will come to this required result, and in left hand side we will replace the values of all whatever we needed. So students, we will start it. First I wrote here y, that is our first equation, and then we will differentiate it with respect to x. So when we differentiate it with respect to x, here what we will obtain, dy over dx. Now when we differentiate it, sin x differentiation is cos x, that's why cos sin x came. Now we have to apply the chain rule to the innermost function, that is sin x. So when we differentiate this sin x, we will obtain here cos x. Again I am repeating, since sin x differentiation is cos x, that's why sin x differentiation is cos sin x. Now according to the chain rule, we have to differentiate this sin x again. So when we differentiate this sin x, multiplied by cos x will come here. So this is our first order derivative. Now we will differentiate it again with respect to x to obtain the second order derivative. So here when we differentiate it again, we will obtain second order derivative, that is d square y over dx square. Now here these are two functions. So whenever we have to differentiate two functions, at a time only one function just differentiate, another function you just keep as it is. So here I differentiated cos sin x. Cos sin x differentiation is minus sin x, and according to the chain rule we have to differentiate the sin x again, that will give us the cos x, and this cos x as it is. Now here first I differentiated cos sin x, that's why in second term I have to differentiate this cos x. So I kept this cos sin x as it is, and this cos x differentiation is minus sin x. So I hope it's clear to you. Here we have the two functions, cos sin x multiplied by cos x. So first I differentiated cos sin x. So cos sin x differentiation is minus sin x dot cos x, and this cos x as it is. Then I kept cos sin x as it is, and I differentiated cos x, and cos x differentiation is minus sin x. Now here we can see that some functions are, means I wrote it as it is by adjusting them. Now we are going to replace, we have to prove this result. Now in this result, in left hand side we will prove the whatever we calculated from equation 1, 2 and 3, and when we replace the values of second order derivative, then we will obtain this, and then tan x multiplied by first order derivative, that is this tan x multiplied by first order derivative, and then y value already given in question, that is sin x, and then cos square x as it is. Means in this equation I replaced the values of second order derivative, then first order derivative, and value of y. Tan x and cos square x I kept as it is. Now in next step, first we will see this cos square x and sin x, and this sin x and cos square x are like term with opposite signs, so they will cancel each other. We are remain with only this term and this term. So I removed it. Now we will start with the second term. So second term I wrote as it is. Here tan I changed as sin upon cos, and these two terms as it is. It already removed. These two terms already removed. Only two terms are remain. Now this cos x and this cos x will also cancel each other, and whatever remains, they are opposite of each other, like terms with opposite signs, so they will cancel and becomes 0. So that is our right hand side, and so left hand side equal to right hand side, hence proved. So to prove this question, students, whatever y is available, from that y we calculated the first order derivative, then the second order derivative, and in the left hand side we replaced the values of second order derivative and second order derivative and first order derivative and value of y. By replacing it, we got our required result. So this question is not so tough. It's very easy question. Only take care of the product of two functions differentiation formula. Easily you can get it. And always take care of the chain rule. Always you should apply the chain rule. You should differentiate till innermost function. And if you have further any doubt, you can write in comments so that we can clear out. Thank you.